Yes, welcome to my YouTube channel, and you're all welcome. In this video, I will walk you through the detailed change notation entity, the relationship diagram for the healthcare system database. The diagram represents the relationships among entities like patients, health facilities, resources, laboratory tests, and more. Let's get started. Entities and attributes. We will first discuss the main entities in this system, each representing a core element of the healthcare database. Here are the entities along with their attributes. 1. Geographical location. This entity contains data about the geographical regions. Its attributes include location ID, which is the primary key, village, parish, sub-county, county, region, population, malaria risk level, health facility count, and reported cases. 2. Patient data. This entry stores information about patients such as patient ID as the primary key, the first name, last name, date of birth, gender, phone number, next of kin, location ID as a foreign key, linking the geographical location and the date added. 3. Health facility. This entity represents healthcare facilities and includes facility ID as the primary key, facility type ID as the foreign key, name, location ID as a foreign key, capacity, contact details, and postal address. 4. Resource. This entity tracks resources within the system and attributes like resource ID as the primary key, facility ID and foreign key, resource type, quantity, last updated and update date. 5. Supply chain. This entity records the movement of the resources. Its attributes are supply ID as the primary key, resource ID as the foreign key, facility ID as the foreign key, quantity shipped, shipment date, expected arrival date, shipped by status, and update date. Laboratory tests. This entity represents laboratory tests conducted for patients. Its key attributes are test ID as the primary key, case ID as the foreign key, text type, text date, test result, and technician ID. Training. As you can see there, this entity tracks training programs for healthcare staff. It includes training ID as the primary key, user ID, training type date, completion status, and update date. Treatment. This entity represents treatments provided to the patient's attributes. Treatment ID as you see all of them right there. So the relationships and cardinalities. Now, let's look at the relationship between entities represented by diamonds. Each relationship also includes the cardinality specifying how entities interact. So the ones like that are in the diamond shape. Located at, that is 1 to n. Yeah. A single geographical location can have many patients. So 1 to n is like 1 to many. However, each patient data record links to one geographical location. Then data form is 1 to n. A single geographical location can have multiple. Pardon me. So data form, that is also 1 to n. So a single geographical location can have multiple epidemiological data entries. This helps track disease trends in a region. So most of these are 1 to many. The ones in the diamond cut, they are 1 to many. And the one this includes each resource can be part of multiple entries in the supply chain, but every entry in the supply chain references one specific resource. Stay with me. Supplied to means each health facility can receive multiple shipments in the supply chain, but each supply chain record links to only one health facility. Subs, which is also 1 to n, 1 to many in short. A health facility serves many patients, but each patient's data record links to a single health facility in the health facility part. Then test 4, that one is n to m, so that's many to many. Patients can undergo multiple laboratory tests, and a single laboratory test can apply to multiple patients implemented through the laboratory tests visit table. You can see it from there. Then undergoes. Patients can receive multiple treatments, and a single treatment can apply to multiple patients. That's actually obvious. Then trained by, which is 1 to many. It's not many to many. Each training program can involve multiple users, but each user participates in one specific training program. So in conclusion, this detailed diagram captures the complexity of the healthcare database by clearly representing entities, their attributes, and the relationships between them. The use of cardinalities one-to-one, one-to-many, and many-to-many ensures that we can understand how data flows and interacts within the system. Yes, so now we're going to go to the SQL. So here we are in our xamp software. This is where we're going to generate our SQL code from. But first you open the software and then you create a table. And the table we're going to create first, you put in all the attributes and their respective data types. And then you also indicate the keys. That's the primary key, as you can see right there. That's the ID. Normally the ID is always in the first field. So from there we proceed to include all the other attributes with their respective data types. So this is a process that will be done for all the tables that was seen in our coursework. We had coursework, so each table there has to be represented here. So after this, you also do it for the same others and repeat the same process. Int represents integer, and so on and so forth. So allow me speed this up so that we can finish this up in time and we can look at the code. So once you're done inputting the table and everything, you export the code and it is downloaded into your PC and you can view it. And right now I'm viewing it through VS Code, and that is the SQL code for my table which I developed in xamp.